Good to go.
Hello, everyone. Rick here. Thank you very much for joining us today for this very special presentation. Today, we have a really exciting presentation about API risk management by Dr. Baljeet Malhotra, who is an award-winning researcher known for his work in open source and API data management. We thank you very much, Baljeet, for presenting this to us, and we welcome you to our community. Without much ado, the floor is all yours.
Thank you so much, Rick and Jack. Really honored to be invited by OWASP Sydney chapter. And this is actually our first event in Down Under. So really honored to be part of this community as well. Thank you for the invitation. Just a quick check. You guys can see me fine. You guys can hear me fine. And you can see my screen as well, which is presenting the title slide.
I can't see your screen at the moment.
Okay, so let me share again. So hopefully you can see it now.
Sure can.
Okay, if my audio breaks down, let me know. I will just turn off my video so that we can gain some bandwidth on the streaming is working fine. But looks like everything is working fine. Audio is okay. So please allow me to continue. Once again, thank you, everyone. Good morning, good evening to everyone, whoever is joining from wherever they are. The title of the talk is a Zero Trust Model. But before I get into the API risk management aspect, let me share a bit more details about myself. So before looking into API risk management and founding TeachLab back in 2017, 2018 timeframe, I started the R&D division of Black Duck Software. If you are familiar with open source risk management, perhaps you're aware of this brand. We were responsible for applying different technologies to manage open source related licensing risk or vulnerability management related issues. Before that, I was a research director at SAP. And actually, I worked out from Brisbane office in SAP, but I was based in Singapore. So I had a connection with Brisbane and fortunate to travel to Sydney and Melbourne as well. So really beautiful country and beautiful place. Before SAP, I was a research scientist and worked with various universities and academia, did my PhD at the University of Alberta and undergrad in India. I started my career as a software engineer, then moved on to apply data science technologies and my training to risk-related problems. And quite frankly, I'm not actually a security expert. OWASP, I'm assuming you guys are the experts here, but my specialization is applying data management, data science technologies to large volumes of data. I just happen to apply these technologies and principles to risk management related problems, either from open source related licensing issues, security issues, and more recently in TeachLab, we are applying these technologies and processes for API risk management. This is the agenda for the rest of the presentation. I'm going to spend 15 minutes or so explaining about what's happening at the global level, how these different API ecosystems are evolving, and then I'm going to bring it down to the enterprise level. I'm going to share what kinds of systems are in place for API management, and then talk about different risks that are posed by these evolving API ecosystems. Then we will look into a particular model that we can take inspiration from to help this manage API risks. I would like to keep maybe around 5 minutes or so as a Q&A at the end. But nonetheless, this agenda is just as a guide. This is not a rigid or written in stone. I encourage participation rather than me pretending an expert, presenting and knowing everything. I really encourage questions and queries from the audience. So feel free to pause me and ask questions, or put it in the chat window. Jack and Nick and my colleague Nicole are there. They will, pinpoint those questions to me, and I'm happy to answer those questions. So let's get into the details. This picture essentially depicts how API ecosystems may look like. I don't need to teach you what APIs are. You are very much familiar with APIs. But just to be very clear, I'm not talking about the APIs that are locally available as a local process or a tool. APIs have been existing for more than decades, but what has happened with the widespread usage of internet, many of those APIs have become web APIs. So payment processing, cloud services management, your enterprise solutions, your social media, all those different products and services are connected through different web APIs. So I'm talking about those, and the rest of the presentation is talking about those web APIs as well. As shown in this presentation, you may have a system that is connecting your enterprise systems, your e-carts, your e-markets with your social media and other systems in place. Now, let me share some of the numbers that might be very interesting to you. You may or may not know these numbers, but please allow me to share with you. A lot of companies are looking into this entire global ecosystem, and very recently, some of the organizations have published their result estimating that 83% of the internet traffic is through these web APIs. Now, this is a mind-boggling number. You can imagine your information that is exchanged over the entire internet, how much of that is being contributed through APIs. We did our own research, and we took a sample of the internet, and we wanted to estimate how many APIs exist, how many vendors are there that are providing these kind of services, what kind of industries are providing these kind of APIs, and what kind of services are enabled by these different APIs. So here are some of the numbers. And as the numbers suggest, we estimated that roughly 1 million APIs we can actually touch upon, we can actually see. But this number may already be outdated, and this number will continue to grow as IoT, AI, ML, no code kind of technologies take a bigger at a bigger scale. We will see more and more APIs. Don't be surprised when these APIs grow into millions and perhaps billions, just like the web grew. Now, what it has to do with the enterprise world. Now, let me take you from that global ecosystem to the enterprise ecosystem. If you look at the bottom of this picture, you will see different tools or processes in place which could be part of your enterprise ecosystem. At the bottom, you see software analysis or network analysis tools. You may have security benchmark tools, or you may have different analytical reporting systems as well. All of these toolings, which are actually enabling your different products and services, might already be connected to different API ecosystems. On the right-hand side, I'm showing API gateways or service meshes. Essentially, these control access to your APIs. And a lot of services or products are already out there in the market that provide these kind of gateway or service meshes. If you move towards the left-hand side of this diagram, at the bottom, you will see marketplaces. You may already be publishing APIs that for internal reasons or external reasons, you may have APIs that are actually commercial, that are being consumed by your customers and partners. So in a way, you are already a API consumer, you're already a API producer. Now, if you move up this diagram, you see different stakeholders. These stakeholders may be consisting of different developers who are responsible for different API integrations or even building different APIs that are owned by you. There may be security experts or security team members that are responsible for the overall security aspects of your enterprise ecosystem or your AppSec colleagues. Now, you may have licensing colleagues or teams that are responsible for intellectual property management, who are responsible for looking at the due diligence aspect from a technology perspective, from a licensing perspective. On top of that, on the left-hand side, you may have communities that are interacting with your APIs for various integration purposes. Because at the end of the day, APIs are to provide seamless integrations within the ecosystem that you live in. Now let me take you to this 35,000 high-level overview, enterprise overview, to the bottoms of this, what kind of APIs we see in this ecosystem. If you look at the very left-hand side, you see a bucket of APIs. I call them external APIs. Now, these are the APIs that you might be exposing to your customers, partners, your developer communities, and whatnot. But these could be APIs also that you're consuming from your external partners as a product or a integration of different products. If you go into the middle, then you have internal APIs. These could be APIs that you build for different business unit integrations. Many ways, and APIs are actually a nice way to expose different data that can be consumed internally within your organization. But this could be also some of the APIs that your partners have exposed, not necessarily they've exposed to the external world, but just to you. So this is kind of a secret sauce for them, and they want to keep it internal. You can see that the very definition of external and internal APIs could be confusing. Now, let me, on top of that, add another dimension. You may actually have APIs that you may not necessarily know. Now, this may come from various sources, and one of the biggest sources is open source usage. As I shared in my brief introduction, we have looked at open source ecosystems, for decades. As open source has taken over the software industry in a big way, 80 to 90% of the applications are built using some open source. And this is true across different industries and business units. Now, if a developer downloads a library from GitHub or other available sources for a particular technical functionality, you may not necessarily know there are some API integrations as well. Now, this way, you can imagine the number of APIs that can get into your ecosystem, with or without your knowledge. On top of that, you may be buying companies, you may be acquiring assets, and these may get integrated within your enterprise applications or ecosystems. And then at that point in time, you have certain APIs that you may know or may not know, but what are the vendors, what are different services that are being provided by those vendors, where exactly these APIs are hosted. So all kind of unknowns come into play when it comes to some of the APIs that you may or may not know. The point I'm trying to make is your API ecosystem may already be very complex based on these two slides that I shared. Now let me share another perspective from an enterprise, yet a global API ecosystem perspective. So this is a combination where enterprise may have a global view of their API ecosystem. And this typically happens when third-party API integrations take place, and that is happening more and more frequently. Now, you may have a vendor that is based in, let's say, Australia or based in the US, but their services might be hosted in another country. This happens all the time because of cost-cutting reasons, and many companies are actually moving away from low-code, no-code, or heavy GUI kind of applications. All they do is they provide different APIs as intelligence. And many times you actually want that. You do not want heavy dashboards, heavy GUI tools to be integrated within your products and services. All you say is, okay, provide me your API, I integrate with my workflow, and there you go. So we will see this ecosystem, this kind of ecosystem will continue to grow. But what is the net impact? The net impact is from a data sovereignty perspective, because at the end of the day, APIs are nothing but transacting data, either a point data or a decision or a volume of data, but they're providing data. And once you have those data integrations through these APIs, your data sovereignty, maybe you can see as a distributed architecture as depicted in this diagram. So this is a real snapshot of an enterprise ecosystem where each dot represents an API vendor or an API where it is hosted in a country as depicted on this map. Before I get into the further slides and classify different risks that is I'm going to share with the audience, let me take a quick pause and see if anybody has any question. Jack, Rick, if you don't mind, I'm actually not able to see the questions that you were mentioning. Are there any questions at this stage, or any other feedback? Am I going too slow, too fast? whatever your recommendation is, please let me know.
Hey, there's no questions so far, but I think everything's great so far, and I'll let you know if anyone says anything.
Okay, great. Thank you, Jack, for the feedback.
No worries.
So let me continue. Before I get into different kinds of risks, let me show you you guys are the experts, as I mentioned. You may be familiar with some of the content that I'm going to share next, but this is a real example of a compromised API where we saw that this API was leaking people's name, their credit card information, not only just that, but also the security codes and passwords that will actually allow us to enable or do the transaction. There are a couple of problems here. First of all, the API is compromised. The authentication is broken, or authorization is broken, or a combination of both. Most importantly, the design itself is flawed. Many of the data should be encrypted or not should be exposed, as in this shown in this example. But this is just the tip of the iceberg. We saw many other examples where we could scrape data or email addresses or people's name or contact information as exposed by these APIs. Here is another interesting piece of research that my team did. Now, we took this NVD data. I'm sure you guys are familiar with National Vulnerability Database, which reports all kinds of different vulnerabilities in systems, operating systems, applications, and whatnot. We took last 10 years or so of data, and we tried to map the vulnerabilities to API specific problems only. So we took the entire data, chunked it to the API specific problems. The middle column tells what is the frequency of some of the API specific problems that we found. And on the very left hand side, you see what problems we are talking about: broken authentication, broken authorization, buffer overflow, cross-site scripting, and whatnot. Whatever vulnerabilities we could map to the API specific related issues. Now here, there is an interesting observation. OWASP, since 2019, came up with their top 10 API security recommendations. What are the top problems that affect APIs? What are their recommendations? Just like application security top 10 recommendations. Now, this is very interesting to see that independently, when we did this research using NVD, the top two problems, broken authentication and authorization, are also the top 5 of OWASP recommendation as well. So this validates that what OWASP is recommending and what we see independently actually makes sense. And within that, authentication and authorization are the key problems that are affecting API ecosystems across the globe. And the rest of the presentation will focus on these two problems in a very detail, and also looking at the models that actually have highlighted these very important dimensions of the security. So what kind of authentication problems we saw? We saw problems like APIs without any protection, with no authentication at all. Of course, you can claim that, oh, these are internal APIs, we don't need authentication. But again, that doesn't make sense sometimes when your internal APIs are exposed through HTTP or HTTPS, and somebody can, access to specific URLs that are linked to your hosted services. We also see cases where you have authentications like API key-based mechanisms, but those are weak keys that we can actually guess. We also see token-based authentication where you can actually predict some of these tokens, especially some of the OAuth integrations, where OAuth is a framework but it really depends on how do you implement it. If there is some standards that you're not adopting or best practices you're adopting, even the best framework that you could use could be broken. We also looked into authorization related problems, because these are the two problems, as I mentioned, were very important problems that our empirical result revealed. Authorization problems, as you understand very clearly, you are authorized but not you are authenticated, but that does not necessarily mean you're authorized to access all different resources. In this case, the nomenclature of the API endpoints was itself a problem. The two examples I gave, where one endpoint relates to department 1, another endpoint relates to department 2. Simply because I was authenticated to access department 1 should not be giving me access to department 2 APIs. But nonetheless, we see this often the case with many other APIs as well. As you know, authorization problems can be divided into two main buckets, function level or object level. So this was basically a more granular level, but the situation could be even more severe when there are certain APIs that are providing function level authorization, for example, admin access. And as you know, if admins are, a lot of the administrative privileges are run or can be integrated through these different API endpoints. Now here, this API was compromised where we could actually access and get access to the admin privileges by simply manipulating the URL that is linking to the API resource. Now, all the different kinds of problem I talked about, authentication, authorization, different kinds of problems may lead to different kinds of risks. Now, just because there is a security breach, the story does not necessarily end there. We must do more than that to actually identify how that security compromise leads to different kinds of risks. So let me spend some time on different how we can classify different risks based on the API authentication authorization or other API security specific problems that we could identify. Now, here is one way we can classify these different API specific problems. Now, in many cases, you have no choice but to prioritize your problems. There is no day in the security framework or your posture where you say, I'm 100% done today. We have the best tools, we have the best process, we have the best training of the people, and we are done. That never happens, as you know very well. It is all about prioritization. It is all about, and that's why scores like CVSS, which helps you to prioritize different vulnerabilities, and you attack those problems which have high score or that are more severe. So when it comes to API risk, it is a very much similar situation. You can take those problems and try to classify them into one of these problems that I've depicted here, and I will explain this in more detail. By the way, I'm not going to claim that this is the only way you can classify your API specific risks. There could be other ways, but this is a really good start, and this could help you understand and kickstart your thought process. So security problems, which is the very first left that I've shown here, you understand it very clear. There is an authentication problem, there is an injection problem, or there is an authorization problem, all kinds of problems you can imagine that are directly related to security or application security problems specific to the APIs. Now, when it comes to legal issues, that is also very clear. Let's say you have an API that is exposing certain customer data or transaction. If those APIs are compromised, you can see the impact. From a legal perspective, maybe customers are not happy. Millions of customer data is leaked through those APIs, and basically you're looking at lawsuits or other kinds of legal issues. So those two problems are very, very easy to understand. They are kind of two sides of the same coin. But financial, operational, regulatory, I will explain a bit more detail and perhaps provide some examples. Let's look at the financial API risks. Now, there could be an API that is transacting dollar value. For example, let's say you have a credit card integration. And as you can imagine, if this API goes down, you have a direct dollar impact because your entire supply chain has stopped and the dollar values are not flowing well. There is a direct financial impact. But that does not necessarily mean that it ends there. Let's take the example of a certain business model in which even tweets can have value or a dollar value or a social media feed. A lot of companies are actually, their business models are built on that. Let's say every tweet has a dollar value because that has a certain social media or sentiment analysis that run on those tweets. So you can see that The financial impact could be your services may get impacted simply because some of these feeds are not plugged into or not functioning the proper way. And you can see the immediate impact on that. The revenue may go down, or the immediate financial impact could be, your services may not be continued by your customers and partners. So financial impact, you do not necessarily need to look from just the dollar value perspective. You need to quantify from a business value perspective. What is the role of this API? What data it is transacting? And what is the financial impact on your organization? Operational risks are even more interesting. And let me share a real example based on that. I was part of a team that was responsible for conducting technical due diligence. And essentially, we were responsible for M&A transactions. So, whenever our organization would go buy companies or acquire assets, we would go as a technical team, conduct some due diligence, work with lawyers and licensing colleagues, to do a holistic view of the technical, financial, business risks. And of course, we will look at the technical risks as well. So the long story short is we bought this company, and 6 months down the road, the application that was integrated, started to choke down the entire part of the ecosystem. We had no idea what was happening. And it was not easy for us to look into the technical aspect immediately because it was millions, or perhaps at least to the order of that magnitude lines of code, and all the tools we had used as part of the technical due diligence, software composition analysis, the security assessment, licensing assessment, you can imagine, could not figure out these issues. And the problem was one particular API which was going into a loop, trying to fetch some data and continue with the rest of the process. Now, since this API was not responding, this was going into the loop and taking so much time, and basically exiting after a certain time. But the net result, it started to choke the application more so frequently because this solution that we integrated now needed to scale to perhaps hundreds and thousands of customers from a startup that we had bought. So the point is, the moral of the story was, this did not have an immediate security implication, did not have any direct legal implication. There was no financial impact, but there was an operational aspect. And also, more importantly, we lost the credibility because of this operational inefficiency. So the moral of the story here is, the operational aspect could also come up if you have not looked into the due diligence from that perspective as well. Now let me move on to the regulatory kind of risks. So these risks are also like a hammer that may strike, once a year, twice a year, depending on what kind of processes that are in place. And again, the real example here is, in one of the audits, we were supposed to disclose third-party integrations. And we failed to do so simply because we failed to recognize that certain APIs, the vendors were based in a specific country, but but eventually we learned the fact that many of their APIs were hosted in AWS or other clouds, in a different country. And as you can imagine, even a simple API integrations like single sign-on may store, email addresses or personal name or other pieces of personal information as part of the single sign-on onto a server. Now that very much, classifies as a personal information if it's an email, phone number. Phone number may be not needed, but of course, first name, last name could be very much stored. So the lesson learned here was, we failed to disclose those third-party integrations simply because we did not know that these APIs were hosted by these vendors that we thought based in the same country that we were doing business in, but not necessarily hosting those services. And that delayed the audit, led to certain other difficulties as part of the business process. Now, let me go into some of the details from a API perspective. As I mentioned, your ecosystem may contains free APIs, public APIs, known APIs, external APIs, internal APIs, all those ecosystems might already be part of your enterprise applications. Now, from a security perspective, you understand very much. The highlight of this security risk assessment is if you do not even know your APIs, then how can you assess the security posture? So, knowing your APIs for either it is a financial risk or it is a regulatory risk is a key to your security posture. And of course, if these are internal APIs, you cannot take things for granted. All the principles that I talked about must be enforced for either financial risk management, for technical risk management, or regulatory risk management, or legal risk management. And I've skipped through some of these slides simply because in the examples I provided, I think you get the picture what I'm talking about. And once again, I want to highlight for each of those APIs, you want to identify, do we know all our APIs? Who's the vendor? What are the underlying terms and services to use those APIs? Free does not necessarily mean that you don't have obligations. Just like open source, a lot of companies started to look from a licensing risk perspective. Then, of course, vulnerability management also kicks in as part of your security posture. Similarly, APIs are a bit more dynamic than even I would say open source usage scenarios. And here, simply you invoke certain APIs, the hosting or the servers or the vendors that are providing those APIs already know they're consuming those APIs. So the point I'm trying to make is you need to go through the entire inventory of APIs, identify which are those APIs, classify them as internal, external, and identify those risks associated with from a risk perspective, from a financial perspective, operational perspective, licensing risk perspective, and other categories that I described. So now we are into the heart of the presentation. We have talked about global enterprise API ecosystems. We have also talked about different APIs that could be part of this enterprise API ecosystem. Now let's look into what kinds of different models we can take to manage our risk. And it is this problem, the kinds of issues I've highlighted, you almost need a Swiss knife like a tool or a process or a combination of all of that to actually solve this problem. Because for each specific problem, you need to have a specific knife, and that's where the title of the slide or the talk comes from. You almost need a mechanism and a process to manage your ecosystem that may have all these tools and processes in place that can help you with API risk management. Now, so let's look at that. What is that Swiss knife that can help us? That Swiss knife, in my opinion, is the zero trust model. And a lot of companies have started to look into zero trust as a framework, not necessarily only for API risk management, but as an overall their enterprise-wide security programs. And I will explain in the rest of the presentation, it has certain core principles. You will see how they can be very, very useful for API risk management as well. But before I go there, let me actually revisit the 7 core principles of zero trust model. Let me take a quick pause at the same time. Jack and Nick, are there any questions at this stage?
Hey, no, not at the moment, no.
Okay. How we are doing on time? I'm just trying to look at my watch. So we have roughly around 25 minutes. Is that correct?
Yep. Oh, look, but we can go longer if need be. There's no rush on our end. It's totally up to you. Yeah, there's about 25 minutes left to the hour.
Okay. Thank you, Jack.
No
So I'll
worries.
try to wrap around 20-25 minutes, and then we'll see if I've spiked enough interest from the audience to ask any questions. So let me start again. So zero trust, as I mentioned, it has 7 core principles. And the very first principle is all data resources or software services you must treat as a resource. Okay, so this could be your an enterprise application. This could be your devices. This could be your applications hosted on third-party services as a third-party services. Pretty much every data source, software, and service must be treated as a resource. The second core principle is all those resources must be accessed through safe or a secured communication network. And that makes sense. As you can imagine, you cannot say that this is my internal application and hence it need not be on a secure channel. So the very core principle, the second core principle is all your resources must be accessed through secured channels. Now, all the resources that you have exposed to secure channels must be accessed through sessions. What do I mean by that? I can give you a good example is from OAuth or API key or other mechanisms that enable authentication. Now, this core principle does not necessarily tell you that how long the session needs to be. All it tells you is there must be a session. You must not give access to resource without any sessions. The fourth core principle is the policies that enable access to those resources in a sessional way through secure channels must also be dynamic. A lot of companies have started to adopt this as a policy. You may see, for example, you change your location and you try to access your email, then there is a notification whether you access that. So you can see that as part of your dynamic policies where time and space are correlated to see whether the policy that is in place to give you access to resources meets the constraints of the security posture that is in place. The fifth core principle is the integrity and the security posture of resources must be monitored at all times. In the context of different security tools might be in place, you can see that certain packet sniffing or other kinds of tools that are in place, you can think of them as part of your monitoring practice. But this is a very, very important piece that you must monitor the security posture of your resources at all times. The sixth principle is, and this is very interesting one, authentication and authorization must be enforced for all your resources. And you can see that very, very importantly, how authentication and authorization is also recommended by this model as well. And as we will see for API ecosystems, how important it is from a security perspective, based on some of the evidence that we see, how important it is for API risk management as well. Last but not the least piece is, regardless of your continuous monitoring practice in place, regardless of your dynamic policies in place, you must collect additional pieces of information to evolve your policies and monitoring mechanisms. When it comes to API ecosystems, I will give you a very a prominent example that will help you understand that what kind of additional information we can collect. But the point of regularly collecting additional pieces of information is that the dynamic policy or the monitoring mechanisms that are already in place may not be sufficient for you to constantly evolve the security posture. Because even if you have an AI based system that is trained by very useful models, but the hackers could be one step ahead of you, and your models may expire. So if you're not collecting some additional pieces of information, these models or the policies may already be outdated to protect you from the security threats. If you want to look into zero trust model, I encourage you to look into some of the resources I've shared on my slide here. There are a lot of other literature available, but I think these are two good resources. one from NIST and one from CSA, that have published some other reports or papers on zero trust model. So now let me take some inspirations from zero trust model and map them onto API risk management um, process or practice that we would like to put in place. The very core principle, which was about treating all your resources as sources your resource, is also applicable to APIs as well. Um, and this essentially means you must treat your APIs as products, and a lot of companies have started to do that. At the end of the day, as I mentioned, APIs are transacting very important pieces of data for your organization, or you are exposing or you're consuming from other organizations. So when you start to treat APIs as products, the very core principle fits very nicely with your API risk management as well. Any API that you have built or you're consuming, you must ensure that this is done through secure channels. Of course, you can have a service that is using HTTP protocol rather than HTTPS. You may have uh, internal API which is hosted on a server that is not necessarily secured. Maybe it's not in DMZ or somewhere else, which is not necessarily protected with the best of security layers that you can build. So API communications must be through secure channels. The third core principle: all your APIs must be accessed through sessional approaches. Now, let me spend some time on this, because some of you may already be making observations that it may not be possible. Why? Because the very purpose of API is to provide seamless integrations, machine to machine communications, or in some cases, you need to iteratively call these APIs. So the ability for you to enforce this constraint may actually defeat that purpose. So you really need to think about your APIs and the ecosystem that they need to operate under, and what kind of business functionalities they need to provide. You really need to, based on those dimensions, you really need to decide what could be a right session approach. Now, this does not necessarily mean that you may have a single approach for all the different APIs that are in place, either from a consumer perspective or a producer perspective. But again, nonetheless, you can or you must ensure certain sessional approaches. The fourth principle was having dynamic policy. This is very much similar to the example I gave about email. APIs need not be treated differently as well. You need to look into time, space, and the other context around API usages, and looked at what kind of policies that must be evolved based on the constraints that you have. For example, you have, let's say, you have an API key based authentication. Now, suddenly you realize that this API key, which was originated from a specific IP address, now is being requested or used from a different IP address. So it could be very much the case where API key is stolen. Now, as you know, once you get an API key, you basically get access to resource simply because that's how you authorize. So the point is, you may need to correlate different pieces of information to come up with policies that could evolve uh, based on different time, space, and context that might be part of your API ecosystem. The fifth principle is about monitoring these APIs constantly. Now, some of the gateways already provide this kind of functionality, starting with authentication layers built as part of um, your mechanism, where you can see who's logging into your systems to actually access these APIs. So you need to have a constant monitoring mechanisms. But it may not necessarily be possible for gateways to have all kind of intelligence to do the continuous monitoring that is needed for API security posture. So you really need to see what kind of monitoring mechanisms you can put in place. The sixth core principle, as we have discussed several times, is about authentication and authorization. Now you can see that even this model is actually emphasizing so much on authentication and authorization uh, uh, frameworks. So it's very, very important to enforce authentication followed by authorization to make sure that your APIs are accessed by legitimate ways, and whatever it needs to be done. You want to make sure that authentication authorization is enforced across all different APIs, regardless of it is internal, it is external, and other cases that I described. Last but not the least, you must collect additional pieces of information. So here, as I promised, let me spend some time, and this could be very, very important piece for API ecosystems and corresponding risk management. And again, there is a real use case that I can share with the audience. Is we were approached by one of our clients, and their problem was they 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 mentioned that they suspect that there are fake registrations happening with their API portal. And even though these users could legitimately register, maybe pay them if these are commercial APIs, but still they perceive this as a threat because they suspected that these could be some of the fake users that might threat their intellectual property, especially because they had certain APIs that can be correlated, to make some business sense or some other aspects that could leak their IP or other, pieces of information. So what can be done in this kind of situation? So there is no single answer to these kind of problems, but some of the thoughts are: can you store payloads? Can you store inputs to those APIs? APIs in many ways, you know. You have a input as a string or as a file or other mechanisms, and these inputs essentially are consumed and structured a query and ran against a database to fetch the answer and respond back. So the entire workflow you can imagine. So you can either store payload, you can store inputs to those APIs, or parameter values, or whatever. But it may or may not be possible depending on the SLAs that are in place. Maybe your customers do not want you to store their payloads. Or if you are exposing your data, or exposing your APIs, then your customers may not necessarily want to store their inputs. So it really depends on uh, what kind of agreements, arrangements you have, or what kind of terms of services you put out there. So you can apply different mechanisms to constantly collect additional pieces of information to evaluate your security posture, evaluate your policies, and make adjustments accordingly. Maybe another thing I can mention here is when it comes to APIs, it's not just important to monitor the posture, security posture, but also the different patterns in which your APIs are being consumed. So monitoring the behavior itself is very, very important of the different users. Now, here is a simple workflow that we have described here that may help you put a process in place for API risk management within your organization. Now, this consists of different stakeholders, different tools or processes that you need to define to manage your risk. So, let me start from the very left. The very first thing you might need as part of your API risk management process is you need certain tools or processes in place by which you can shift left and enable or empower your developers to constantly scan or discover different APIs. Now, as I mentioned in my uh, uh, earlier slides, that one big hole in this entire risk management space is the APIs that you don't know. Because if you don't know what you don't know, you don't know. And if you don't know, then how do you manage those risks? So, what kind of tools and processes you can put in place to actually uh, manage and discover those APIs? So, by shifting left, you can look at applications, you can look at the networks, but you need to have an appropriate tools and process in place to have that capability. Once you put that in place, you must identify different security, technical compliance, licensing risks that can be associated with your API ecosystem. And doing that one time may not be enough because you need to constantly track and monitor those changes that can pose different risks to your organization. Now, as I mentioned in my enterprise ecosystem overview, there could be different stakeholders. So you need to inform your different stakeholders to make sure that they are aware of different aspects of API risk management that they need to play a role in. And this could be licensing colleague, this could be a security expert, this could be a product owner team, this could be an operational security team or a security response team. So you can see different players that could be part of this ecosystem that you must alert. Last but not the least, must make appropriate recommendations to manage your risk. And the recommendation could be as simple as this API is hosted on that server. Why it is there? It must be moved to this particular location. Okay, so it could be a long process, though, if it is a third-party API. But if it is internal, then maybe DevSecOps needs to work with IT to make sure that the provisioning and the deployment works in a proper way. But the recommendation could be as complex as we have discovered this API. Well, this was an internal API, what it is doing in this application, and this application was actually checked out as an open source project, and it is already on GitHub, and now it is exposing one of your internal APIs, and that's not necessarily a good situation. Worst, if there was no authentication mechanism in place, simply because whoever built it thought, oh, this is just internal API. So you can imagine the recommendation could be very, very complex depending on the situation. But again, the ability for you to discover, identify, track, monitor, and make recommendations to different stakeholders is the workflow you want to put in place. Now, I'm very much towards the end of my presentation, and we have left with almost like 5 minutes or so. I think this is perfect timing for us to summarize the presentation. Now, what I presented today is very important from a global perspective. The world is evolving, digital economy is evolving, and APIs are playing a very important role in that ecosystem. Your API risk management cannot be handled without having a governance process in place. So and as I described as a simple workflow in the last slide, that the key to your API risk management is the ability for you to put in place, empower your organization, empower your developers, empower different stakeholders to govern your APIs in a seamless way. And part of that recommendation I made was that zero trust can be a very nice core piece within this governance model, which will help you manage your API risks. And I also talked about the 7 core principles that will help you with putting this process in place. As APIs evolve, this the different policies that you can put in place from authentication, authorization perspective, or the 7 core principles I talked about. Zero trust could be a really good starting point if you have not looked into API risk management and how to handle the corresponding cases. I've also mentioned a resource, and oftentimes we do a more longer presentation where we actually talk about certain different practical aspects of the different risks that I talked about, and we demonstrate some of the use cases through the community platform that we have built. So the link is provided here, but unfortunately, that will require more time. So we are pretty much on time now, and I do not want to, delay this presentation. So we will leave it there as a link, but I encourage you to look into this platform. The link is provided there, and that will basically give you a good resource that we have built for the community, where you can look at how to explore different APIs, how to organize different APIs, how to look into the security aspect, how to run different security test cases, how to look into the different licensing and operational risks. And many of the use cases are built into this platform. So I encourage the audience to look into this platform. The sign up is free. You simply go to the login page, sign in, and the access remains free for the OWASP and other community members. If you are interested, we can also help you with a complimentary assessment. If this inspired you and you want to look into this into more detail, we'll be very happy to have a separate discussion. Please reach out to Jack and Nick and my colleague Nicole. She might be there as well. And this is my contact information. Please reach out to us and we'll be very happy to provide some guidance. So with this note, I'm pretty much done. So I would like to thank again the audience, and thank you very much, Jack and Nick and the rest of the OWASP Sydney team. Really honored to be part of this community, and I give it back to you for your concluding remarks. Or if there are any questions, I'm happy to answer as well.
I actually have a couple of questions for you. Thank you very much. That was a fantastic presentation, very interesting. Thank you very much. I think I learned a bit about how to use zero trust in APIs, which is something I think most of us not really think about, and we should. I think APIs is like the thing in the back of our minds that we should pay more attention to. Now, throughout presentation, you mentioned that we should perform API monitoring. Do you have any open source tools or anything like that you could recommend that could help you perform this monitoring?
Yeah, sure. So I won't take any vendor's name, but certainly look into some of the gateway solutions that might be available. So right after this meeting, I can share some links that you can share with the audience. Yes, so there are some open source tools, but monitoring could also be part of your existing tooling or the process that might be placed. But I'm happy to provide certain links that will help the audience look into some of the open source resources that are available.
Fantastic. Oh yeah, and that was my next question. We could get a copy to our presentation. You have sources. I know that you had one wanting to teach lab, and but before that there was another slide that has a set of resources. It would be good if we could put them in the comments so people come and see a presentation, they could get access to all
Yeah,
these.
absolutely. I'll be more than happy to share that slide, and please feel free to share with the audience. And I'm just copy and pasting in the chat window as well, so that everybody can see that. So this is one resource, which is by NIST. This is another one by Cloud Security Alliance. These are the resources uh, on zero trust model, and I will also share our own resource. And this is useful if you want to explore different aspects that I described today, especially what are different ways you can organize an API. Part of the problem is APIs are evolving in hundreds and tens and thousands, perhaps, within an organization, within a business unit. So your ability to organize your APIs into a single marketplace or a repository could be very, very useful. So you can, the third resource is you can actually go into the system, explore those, look at what are some of the ways we are classifying different risks, and are happy to provide some additional resources as a follow-up through email.
Fantastic. Thank you very much for that. Much appreciated. Um, so yeah, we will definitely share all of that with our communities. I think everyone appreciates all these fountain of information, a topic that is not very well known. Or, as you mentioned, it's something we all know about. We got all these APIs, but I don't think anyone really knows what to do with them when it comes to security. So yeah, thank you very much. You got any more questions, Jack? Or?
No, I don't. And there's none in the comments either. But I've taken all the links that you've just provided, and I've put them to YouTube comments, so people will be able to access them now if they're watching live, or if they're watching the recording at some point in the future, they'll be accessible there as well.
Fantastic.
Great. Thank you so much, Jack. Thank you so much, Rick, and the rest of the team. If you're done, I'm happy to exit and let you guys go back to your work and do whatever you need to do. Thank you so much for the invitation. Really honored.
Thank you very much for your time, and thank you for the presentation. It's been great.
Thank you so much. Thank you, Jack. Thank you, Rick. Bye-bye. Have a good night.
You too. Take care.